So I welcome you all to this second video of physics online practicals. In the last video, we have discussed meter scale, thermometer and Vernier caliper in detail. Now today in this video, we are going to discuss about micrometer screw gauge, how to read a micrometer screw gauge and its zero error, etc. Okay, so in the last video, we have discussed meter scale, thermometer, Vernier caliper, and today we are going to discuss micrometer screw gauge. So we have these two types of micrometer screw gauge, or short form I can use at MSG or simply screw gauge, depending upon the manufacturing companies. So here threads are visible and here polished fine surfaces available. Here scale is same, that is 0 to 5, and here scale is visible, that is 0 to 5. So we have these two types of micrometer screw gauge available in our physics lab. Now, as we discussed earlier, what is least count? A question mark is there. What is least count? Answer is it is the smallest possible measurement using an instrument. Okay, and here the formula is value of smallest division on main scale divided by total number of divisions on Vernier scale. So this is the general formula. Once again, smallest division on main scale divided by total number of divisions on Vernier scale. So here instead of Vernier, we have to replace the word Vernier by using circular scale in case of micrometer screw gauge. Okay, so the new formula for micrometer screw gauge goes like this: smallest division on main scale divided by total number of divisions on circular scale. So here inside the bracket we can write CS, that is circular scale. So this is the photograph of micrometer screw gauge and its different parts. So first we can start with the frame of the micrometer screw gauge, which is used to hold the micrometer with our fingers. On the frame, 25 by 1 mm is visible, is nothing but the range and least count of the micrometer screw gauge. Generally, manufacturing companies mark 1 mm as the least count in terms of millimeters. But in our physics lab, we use centimeter as one of the scales to measure the small length, and 25 is the maximum possible range of length which we can measure with the help of this micrometer screw gauge. So if I start with the left hand side of this screen of or the micrometer screw gauge, here fixed anvil is there, yellow one, and this one the arrow is pointing toward the fixed anvil. So this is the one measuring face which is very fixed. Okay, and opposite to that spindle is there, opposite to fixed anvil spindle is there, which moves to and fro motion with respect to rotation of the circular scale. These two are called as measuring faces. After measuring faces, we have a lock like this on the micrometer screw gauge. This is used to lock a particular reading. Okay. Now after lock, we have datum line or central line marked on the main scale at the center, which is as shown in this diagram, and below that some divisions are marked, and above that 0, 5, 10, 15, 20 and 25. Of course, after 5 digits of main scale are not visible. Here 0 and 5 are visible. So this is the main scale. After main scale we have a thimble, and on the thimble, on the periphery of the thimble, circular scale divisions are marked, and the circular scale is available from 0 to 99. That is total 100 divisions are there on this circular scale. Okay, and at the last we have a ratchet stop. So this is the micrometer screw gauge and its parts. Now once again the flow chart goes like this: how to read an instrument. The flow chart is: first one, observe the instrument and the scales carefully. observe its unit, figure out the main scale and the value of smallest possible division on it. Next, count the number of divisions on vernier scale, that is here we have to modify by circular scale, okay. Then find out least count, take the readings by using the formula, that is total reading is equal to MSR, that is main scale reading, plus inside the bracket CSR into LC. So here I have modified the formula MSR plus CSR into LC. So what is CSR? CSR stands for circular scale reading. Okay. Now, before that, we have to discuss about the some terms and things which are there or fixed with the micrometer screw gauge. So first one is the pitch. So what is pitch? Pitch is there for a screw, and here we have to discuss pitch of the screw gauge. The pitch of the screw is the distance moved by the spindle per rotation. To find out this, the distance advanced or traveled by the head scale or main scale over the pitch scale for a definite number of complete rotations of the screw is determined. The pitch can be represented as pitch is equal to distance moved by the screw divided by number of full rotations given, and hence the least count of micrometer screw gauge can be obtained as pitch divided by total number of divisions on circular scale. Therefore, we don't know the exact value of pitch. Okay, so let us calculate the value of pitch, but before that, once again try to understand what is the meaning of pitch. So here I have tried to explain you pitch. What is pitch? So it is the distance between two consecutive threads of the screw. Okay, it is equal to one complete rotation of the zero of circular scale. Now, if we consider the example of this micrometer screw gauge, I think this photograph is visible to you. So whatever the distance is there, if I mark this as thread number 1, then 2, 3, then 4, and thread number, this is 5 and this is 6. So whatever the distance is there, distance between thread number 5 and thread number 6 is called as the pitch. So totally is threads of the screw. So this is pitch, distance between two consecutive threads. Okay, it's called as pitch. So if we have a micrometer screw gauge like this, then to understand it deeply, we can magnify the main scale, and if we magnify this part, we can come to know the value of smallest division on main scale. So here 0, between 0 to 5 we have 1, 2, 3, 4 and 5 divisions. Okay, so here between 0 and the first division, the value is 0.1 centimeter, that is the smallest division on the main scale. Okay, now if we want to count the total number of divisions present on the circular scale, and if it is not visible properly to you in this photograph, let us magnify the circular scale. Now here in this circular scale, magnified image of the circular scale, 0 is visible at the center, and at the top 10 is visible, and at the bottom 90 is visible. So this would be the 98th division. Okay, 98th division. So 0 to 99 means total we have 100 number of divisions. So it is a whole number. Okay, whole number. So total number of divisions on circular scale is equal to 99 and 0, that is 100 divisions. Okay, now let us remember the earlier formula, that is pitch is equal to distance moved by screw divided by number of full rotations given, that is equation number 1. Therefore LC of micrometer screw gauge, remember we are discussing the micrometer screw gauge now. Therefore, we have calculated the value of pitch, okay, divided by total number of divisions on circular scale. So the value of pitch would be equal to the value of smallest division on main scale, that is equal to 0.1, and just now we have counted the total number of divisions on circular scale, that is equal to 100. Therefore 0.1 centimeter divided by 100 is equal to 0.001 centimeter is the least count of micrometer screw gauge. Now in this slide, how to read the screw gauge, here we have to understand what is error in the measurement. Of course, with every measurement and with every measuring instrument, an error is there. So this micrometer screw gauge is not free from the error. That error is known as zero error. Okay, now try to understand the meaning of zero error of the micrometer screw gauge. If the fixed anvil, remember our earlier diagram, if the fixed anvil and movable spindle, that is inside the bracket, measuring faces of screw gauge are brought in contact without applying any pressure, okay, and the zero of the circular scale does not coincide with the reference line, there is a zero error. Okay, simply if the zero of circular scale is not coinciding with the datum line or central line, okay, if it is not coinciding, then the zero error. Okay, so depending upon the coincidence, we have positive error and the negative error, that is types of errors in the micrometer screw gauge. So in case of positive zero error, if the zero of the circular scale is below the baseline of the main scale, okay, below the baseline of the main scale, then the error is positive zero error and correction is negative. Okay, and second one, negative zero error, if the zero of circular scale is above the baseline of the main scale, then the error is negative zero error and correction is positive. Okay, now here I have drawn the diagram of thimble and some parts of the micrometer screw gauge. So here is this reference line. RL stands for reference line, central line or datum line, and zero of main scale is visible. Now here there is no gap between the measuring faces. Of course, the measuring faces are not visible in this slide. Okay, but here we have to consider that there is no gap between the measuring faces of the screw gauge, and if the datum line or the central line is exactly coinciding with the zero of circular scale as shown in this diagram, then zero error is absent. So this is the condition of no zero error. Both are coinciding. Both means if this reference line and the division of zero both are coinciding with each other, then the condition of no zero error, as I told you in the last slide. Now next, if you observe situation like this, again this is the reference line, the central line of main scale is the reference line. Okay, now here the circular zeroth division of circular scale lies below the reference line. Okay, so this condition we can explain as there is no gap between the measuring faces of screw gauge, and if the zero of circular scale lies below datum line, then positive zero error is present and the correction is negative. So this is the condition or photograph of positive zero error. Now this error is to be totally reduced or to be minimized, okay, from the total reading, then we can obtain the corrected reading. Therefore corrected reading is equal to total reading minus inside the bracket positive zero error. Now here we can come to know the value of positive zero error by coinciding, observing the coinciding CSD into LC. So in this case here coinciding VSD is 0, then 1, 2, 3, 4, 5 and 6. So this as I indicated it by arrow, sixth division is coinciding. Therefore, 6 into 0.001, therefore positive or plus 0.006 centimeter is the value of error. Of course, positive zero error for this photograph only. Okay. The value of zero error, of course, positive or negative, depends on type of micrometer screw gauge. It varies from one micrometer screw gauge to another micrometer screw gauge. Okay. Now, in this next photograph or the diagram, again, this is a reference line of the main scale, and here 0 of main scale is visible. Now, in this case, 0 of circular scale is above the datum line. Okay, and this condition can be expressed as there is no gap between the measuring faces of screw gauge, and if the 0 of circular scale lies above datum line, then negative 0 error is present and the correction is positive. So you should remember that correction is opposite with respect to the 0 error. That's it. Okay, so this is the condition of negative 0 error. Okay, once again, the reading can be corrected as corrected reading is equal to total reading plus inside the bracket negative 0 error. Okay, so this is obvious that this division of circular scale is above this reference line. Okay, and just count the number of divisions. So here for you 80, then 85, 86th division. Okay, according to you 86th division is coinciding. Okay, sorry, not 86, 87, 87th division is coinciding. If you observe it carefully, 87th division is coinciding, but here for the calculation of value of negative 0 error, we have to count it from 0. Okay, so with respect to 0, 0, then 90 means actually 10, and 11, 12, and 13. Then I can say that coinciding CSD is 1313 into LC. So therefore, minus 0.013 centimeter is the least, not least, is the value of negative 0 error. Okay. So in case of positive 0 error, now in this diagram, observe this diagram very carefully, and if we have so here we came to know the positive error and the negative error, that is negative 0 error and positive 0 error. So let us have an example of positive 0 error in case of micrometer screw gauge. Now observe the main scale and the circular scale as shown in this diagram. Now correction for positive error. So here we can say that if this is 0, then this would be 1, and 1.2 is the main scale completed by the circular scale. And now this 0 lies below this datum line. Therefore, coinciding division is 1, 2, 3, 4. Fourth division is coinciding. Therefore, as usual, the formula is corrected reading is equal to TR minus positive 0 error. Therefore, TR is equal to MSR plus CSR into LC. The next step. Therefore, MSR is equal to 1.2. So this value MSR is equal to 1.2 plus 4. This is this value 4 into 0.001. Okay, so total reading is equal to 1.204 centimeter. This is total reading as measured by you before correction. Okay, so corrected reading is equal to 1.204, the same, minus value of positive 0 error, that is 0.006, which is obtained from our earlier slide number 15. Therefore, 1.204 minus 0.006, it would be equal to 1.198. So reading, actual reading taken by this micrometer screw gauge is this one. So corrected reading is 1.198. Okay. So this is actual observed reading on the screw gauge. Now, once again, second example for positive zero error. Here the formula is same, and now we can focus on the main scale. So the value of main scale is, if it is 0, this is 0 0.5, 0 0.6 and 0 0.7. 0 0.7 is coinciding with division of CSR. Therefore, MSR is 0.7 plus 0 into LC. Therefore, it is 0.7. Therefore, 0.7 minus value of positive zero error. Once again, it is obtained from slide number 15, and therefore corrected reading is equal to 0.694 centimeter. Therefore, I can say that the actual observed reading with the help of this micrometer screw gauge is 0.694 centimeter. Okay. Now, third example, in case of negative error, once again the formula remains same, but change is there in the sign. Okay, so here this is and this is. So total reading is equal to MSR plus CSR into LC. Now in this case also 1.2 is the main scale plus 4th division, which is coinciding with respect to reference line, 4 into 0.001. Therefore total reading is equal to 1.204. Therefore 1.204 plus value of negative zero error, that is inside the bracket, minus 0.013. This value is obtained from earlier slide number 16. Therefore corrected reading is equal to, actually we have to add this value in this main scale reading. Therefore it is equal to, corrected reading is equal to 1.217 centimeter. Therefore I can say that the actual observed reading on this screw gauge is 1.217 centimeter. Now, fourth example, in case of negative error, again the formula is same, and here observe main scale, that is 0.7 and 0 into LC. Therefore it is 0.7, again 0.7 plus negative zero error, which is obtained from slide number 16. Therefore, corrected reading is equal to 0.713 centimeter. Okay, so I can say that actual observed reading with the help of this micrometer screw gauge is 0.713 centimeter. Okay, now here if we have actual photograph of this screw gauge, the central line is visible. Now, negative zero error is 6 divisions with respect to 0 of circular scale. Okay, so 6 into LC here. So 6 into LC, sixth division is coinciding. Therefore, 6 into LC is equal to 0.006 centimeter. Therefore, this is the formula. Total reading is equal to MSR plus CSR into LC. Now, if you observe, there is no gap between the measuring faces. Now here central line is visible. Now this circular scale division of 0 is not exactly coinciding with this reference line. It means we can say that positive zero error is present, and this is the formula for total reading and the corrected reading. Okay. Now once again the actual photograph for positive zero error of the micrometer screw gauge. Here it is clearly visible that two divisions, 0 of circular scale is below 2 divisions. Okay, so once again the formula. Then how to read the actual measurement. Okay, so here in this case complete MSR is 0.1. 0.1 is completed, and the 0th division of circular scale is coinciding with this. Okay, so coinciding 0 is 0 and positive zero error is 2, because we are using the same micrometer screw gauge. Therefore, the total reading is equal to MSR plus CSD into LC or CSR into LC, that is 0.1 plus 0, that is total reading is equal to 0.100 centimeter, Therefore, corrected reading is equal to 0.100 minus 0.002, that is the value of positive zero error. Therefore, 0.098 centimeter is the actual reading taken by this micrometer screw gauge. Now next example, here complete MSR is 0.2. Again the zero of circular scale is coinciding with the reference line. But remember the value of positive zero error is 0.002 centimeter. Therefore total reading is equal to 0.2 plus this much LC, that is total reading is 0.200 centimeter. Therefore corrected reading is equal to CR is equal to 0.200 minus positive value of zero error, that is plus 0.002. Therefore it is equal to 0.198 centimeter. Okay. Now here in the third example, complete MSR is 0.4 centimeter. So here 0.1, 0.2, 0.3 and zero point 0.4, that is 0.4 main scale is completed. And now here this is 40, 39, 38 and 37. So here 37th division is coinciding and value of positive zero error is 0.002. Therefore total reading is equal to 0.4, that is MSR plus CSD 37 into 0.001, that is 0.437 centimeter is the total reading, and after correction, that is corrected reading is equal to 0.437 minus 0.002. Therefore it is 0.435 centimeter is the actual reading. Okay. Let us take another example. Complete MSR is 0.5, and here on CSR we can observe 60, and below 60 we have 59 and 58. So clearly this division, that is the 58th division, is coinciding with the reference line. Therefore coinciding CS division is 58 and the value of positive zero error is 0.002. Therefore main scale reading is 0.5 as it is obvious, and 58 into LC. Therefore total reading is 0.558 centimeter. Therefore total reading minus positive zero error. Okay. So here 0.558 minus value of positive zero error, that is 0.556 centimeter is the actual reading. Okay. Now in the next example 0.7, see it is here it is 0.5, 0.6 and 0.7. 0.7 is the complete reading, and coinciding division here now is this is somewhere 90, this is 0, and below 0 we can observe 5 divisions. Okay, it means it is 95. So 95th division is coinciding with the reference line. Therefore MSR is 0.7 and CSD is 95 into LC. Therefore 0.795 is the total reading. Therefore total reading is minus positive zero error, that is 0.795 minus value of positive zero error, that is 0.002, is equal to 0.793 centimeter is the total actual reading. Okay, now here let us have actual measurement. We have a nail and we have to find out the diameter of this nail. Therefore the complete MSR is 0.6 and coinciding with CS division is 21 and the positive zero error is same. Therefore MSR is 0.6 plus 21 into LC, that is 0.621 is the total reading, and after correction we have that is 0.621 minus 0.002, that is 0.619 centimeter is the actual reading, actual diameter of this nail. Okay. So we have another example, that is thickness of glass. So complete main scale is 0.2, which is obvious from the main scale, and coinciding CS division is 18, and the positive zero error value is same. Therefore, 0.2 plus 18 into LC, that is 0.218, that is total reading is 0.218 centimeter, and the corrected reading is 0.218 minus 0.002. Therefore, 0.216 centimeter is the actual thickness of this glass. So this much is the thickness. Okay, actually it is very magnified photograph. Now, after thickness of the glass, we have to find out the diameter of wires, of course, which is very small. I think it is less than zero point 0.1 centimeter. Okay, and let us find out the diameter of these three wires. So here, wire number 1, complete MSR is 0. Okay, so here MSR is 0. Just observe coinciding CSD, that is 61, and the same positive value of zero error. Let us magnify the coinciding division, that is this is 60, and just above 60, 61st division is coinciding. Therefore, total reading is equal to 0 plus 61 into LC, that is 0.061. This is total reading. Therefore, total reading minus positive zero error. Therefore, 0.061 minus 0.02, that is 0.059 centimeter is the actual diameter of the wire number 1. Okay, so here is wire number 1. Now for second wire, again complete MSR is 0. Coinciding CSD here now is 59. Okay, and the same micrometer screw gauge, therefore positive zero error is same. In this magnified view, we can come to know the coinciding CST is 59. Therefore, total reading is equal to MSR is 0, 59 into LC. Therefore, it is 0.059 centimeter. And in case of correction, 0.059 minus 0.002, that is 0.057 centimeter is the diameter of second wire. Okay, now in case of third wire, again complete MSR is 0. Now in this case, coinciding CSD is a little bit changed. It is 63. Let us magnify the CSR, and screw gauge is same, therefore positive zero error is same. So here 60, 61, 62 and 63. So this value is clearly visible to you. Therefore, total reading is equal to MSR plus CSD into LC. Of course, MSR is 0. Therefore, 63 into LC, that is 0.063. And in case of correction, 0.063 minus the same value, that is 0.061 centimeter is the actual diameter of wire number 3. Okay, so now if we have another micrometer screw gauge like this, and presently we don't know the value of zero error of this screw gauge, so let us find out the value. Let us magnify the circular scale. So here no gap is present between the two measuring faces. Still, 0 is not visible. Okay, it means 0 is invisible, or it is beyond the circular scale. Okay, but here we can observe 80, 70, 60 and 50. Okay, so visible coinciding CSD is 67. So here is the reference line, and in front of reference line, opposite CSD is 65, 66 and 67. Okay, so 67th division is visible to you presently. Okay, but in case of negative zero error, it is negative zero error because 0 lies above the above the reference line of main scale. Okay, so if it is negative zero error, therefore 67 instead of 67 with respect to 0, this should be the value of this division should be 33. Okay, so 100 minus 67 is 33. So 33 into LC, that is minus 0.033 centimeter. Minus sign indicates that this is the negative zero error. Okay, so minus 0.033 centimeter is the value of negative zero error for this particular micrometer screw gauge. Now let us have some examples with this micrometer screw gauge. So here is wire number 1. Again we can observe that the MSR is 0. Let us have magnified view of CSR. Again MSR is 0 and CSD is 33, that is 30. Here is 30, 31, 32 and 33. 33 just above reference level or reference line, but we can consider it as 33. Therefore CSD is 33 and the CSR is 0.033 centimeter. CSD means coinciding division, and coinciding division into LC gives us circular scale reading. Okay, so slight difference is there between CSD and CSR. Okay, now let us have total reading. Total reading is equal to 0 plus 33 into LC, that is 0.033. That is 0.033 centimeter is the total reading. Therefore, corrected reading is equal to TR plus negative zero error. Therefore, this is very simple example. So 0.033 plus 0.033. So 0.066 centimeter is the actual diameter of this wire. Okay. Let us have second example. Let us change the position of wire. Now here, once again, we can observe MSR is 0, and if we magnify the circular scale, we can observe that MSR is 0, still 30, 31 and 32. 32nd division is coinciding, therefore CSR is 0.032 centimeter. Therefore total reading is equal to 0.032. Now I will not read everything. You will come to know the total reading is 0.032. Therefore this is total reading, and total reading plus negative zero error, since correction is to be positive. So therefore remember our earlier slides, the discussion of zero error in case of micrometer screw gauge. Therefore, correct reading is 0.032 plus 0.033. Therefore, it is equal to 0.065 centimeter. Okay, so this is the actual diameter of this position of this wire. Okay. Now, let us have a bigger wire and let us try to find out MSR and CSR. Okay. So once again here, MSR is 0.1. It means this wire is little bit bigger than the earlier one. So it has completed zero point 0.1 as MSR, and coinciding division is here 60, 61, 62 and 63. So here I can write 63. By mistake I have written it is 32, but it is 63. Okay, so CSD is 63 and CSR is 0.063 centimeter. Now total reading is equal to 0.1. Now you have to add this 0.1 into this, therefore 0.163 is the total reading, and in case of correction 0.163 plus 0.033 is equal to 0.196 centimeter is the actual diameter of this wire. Okay, so nearly equal to 0.2 centimeter. Now this is the photograph where I have tried to show you how to measure the thickness of this piece of paper. We have printing paper in our lab, and I have tried to show you we can measure the thickness of this piece of paper. Okay, so here if I magnify the main scale and the circular scale, here I can, or we can see that MSR is 0.0 centimeter, which is very obvious from this magnified view. and CSD is 81. 81 means this is 80 and just one division, 81th division is coinciding. Actually, this is the position where 81 and 80, the reference line is just exactly at the center of 80 and 81, but we can consider it as 80 or 81. Okay, whatever it may be. So here I have considered 81 as CSD and CSR is 0.081 centimeter. Now total reading is equal to 0.081 centimeter. Therefore, total reading plus negative 0 error. Therefore, corrected reading is 0.081 plus 0.033, that is 0.114 centimeter is the total reading of this. Actually, total reading means thickness of this paper. Okay. So with this, we came to an end of this micrometer screw gauge. And thank you for your attention. And don't forget to like this video, and if you have some questions or queries regarding experiments in physics or any physics concepts, you can comment below, and don't forget to share this video with your friends. Okay, so thank you.